The repair I'm working on cost our customer money. When their phone went dead in the middle of a customer call, they lost business. The problem was caused when an electrostatic discharge damaged a circuit pack, and when the circuit pack was damaged, zap. We had to spend time and money to locate and repair the problem and apologize to our customer. Damage to that circuit pack and our reputation could have been avoided if the previous repair tech had taken some simple precautions against electrostatic discharge. Circuit pack damage caused by ESD is a bigger problem than you might think. Circuit packs can cost our company anywhere from $200 to tens of thousands of dollars. Just think of what you could buy with that kind of money. Anything from a cart of groceries to a pretty nice family car. In order to help you prevent damage to circuit packs, we need to take a closer look at electrostatic discharge. Electrostatic discharge, or ESD, is the sudden rapid transfer of a static charge from one object to another. ESD occurs between different objects having different electrical potentials. One object is more positively charged and one more negatively charged. The objects attempt to balance their charges by releasing and accepting electrons. Usually this electrical charge flows through a spark between the two objects as they approach or contact each other. It's that small spark that can damage circuit packs and cause microprocessor upsets. Humidity also plays a part in the amount of ESD which can occur. As the relative humidity in the air goes down, the greater the static charge buildup. An example of ESD most people are familiar with is the shock you may receive when you walk across a carpeted floor and then touch a metal object. Most people think ESD occurs only when they feel a slight shock or see an actual spark, but in order for us to feel an ESD, the discharge would have to reach about 3,000 volts. ESD-sensitive components, like those on this circuit pack, can be damaged or affected when exposed to a discharge of 250 volts or less. This chart illustrates typical voltage sensitivity. There are 3 ESD failure models you need to be aware of in order to avoid the damage and disruption they cause. The first is the charged device model, or CDM. Here's an example. This circuit pack can become charged and eventually damaged if it's handled or transported without taking ESD safeguarding measures. When not fully enclosed in its protective packaging, the pack can share the charge of the person holding it, the surface it's placed on, or the vehicle transporting the pack. And once charged, the pack will discharge to any conductive surface. This is true even if you're wearing a wrist strap. And when a circuit pack picks up a charge, say of 1,000 volts in average relative humidity, it can take up to 10 hours for the charge to decay to 100 volts. If humidity is low, charge decay could take much longer. The second failure model is the field-induced model, or FIM. Field-induced failures can occur when an unprotected circuit pack is handled within 1 foot of a source of electrostatic or electromagnetic fields. The circuit pack can be damaged when it's grounded in the presence of that field. And field induction can leave a charge on the circuit which can cause a charged device model failure later. This can happen when the pack is handled near a video display terminal or even a styrofoam cup. The third ESD model is the human body model, or HBM. As we said earlier, this most commonly recognized ESD event occurs when you walk across a carpet and touch a metal object, such as a door handle. According to tests performed at 55 field locations, technicians generate an average of 1,200 volts after walking across this vinyl floor during average relative humidity. This is more than 5 times the voltage that can damage a circuit pack component. This chart shows typical electrostatic discharges created in everyday activities during both low humidity and high humidity. As you can see, static charges occur in our everyday activities and can cause discharges that damage equipment crucial to operations. That includes circuit packs or any ESD-sensitive devices, including data sets, electronic printers and modems, multiplexers, digital loop carriers, and fiber optic systems. Now, let's take a look at some measures designed to reduce the risk of ESD. There are 4 general rules to keep in mind when handling circuit packs and other ESD-sensitive devices. Rule number 1, always maintain an ESD-safe environment when handling circuit packs and tending systems. All non-essential charge-generating materials and devices should be kept at least 3 feet away. This table lists typical charge generators including work surfaces, chairs, clothing, and floors. Rule number 2, protect all circuit packs in fully enclosed ESD protective packaging while stored or in transport. This includes circuit packs you may believe are defective. Rule number 3, wear an approved wrist strap that has been properly tested each day prior to use before opening a circuit pack container. And rule number 4, make sure that all contractors and other employees follow our first 3 rules. If these rules sound familiar, they should. They're contained in this electrostatic discharge job aid. Here's an overview of our job aid along with more tips on avoiding ESD. The ESD job aid begins with a menu taking you through, number 1, background on ESD, including the failure models we mentioned earlier. Number 2, replace and install circuit pack, which gives a step-by-step detail along with questions you'll need to ask yourself as you work through the circuit pack installation procedure. Number 3, covers measures and precautions against damages caused by ESD. And number 4, includes a technician checklist and acknowledgement of performance. The ESD job aid is designed to be easy to use. For example, to review the wrist strap test procedure, turn to section 2A in the job aid, Test Wrist Strap. In step 1, if using an older tester, put the tester in the 10 meg-ohm position. Newer testers are preset to test. Step 2, attach the wrist strap cord to the cuff. Step 3, gently pinch the cuff between your middle and forefingers and thumb while allowing the metal back plate attached to the cord to hang below, making sure you don't let the metal back plate touch your hand at this time. Step 4, using your other hand, plug the banana plug of the cord into the jack on the wrist strap tester. Step 5, with your free hand, press the touch plate and observe the LED indicators. If the pass indicator lights, then move on to step 6. If the fail indicator lights, go to step 9. Step 6, you then put the wrist strap around your wrist and adjust to fit with slight pressure. Moving to step 7, with your free hand, press the touch plate. Step 8, wiggle your wrist to shake and stretch the cord and observe the LED indicators to make sure it's not making an intermittent connection. If the pass indicator lights, the wrist strap and cord have passed the test. You may now unplug the wrist strap from the tester and begin work. If the fail indicator lights, replace the cord and return to step 2. Step 9, rotate the cuff 180 degrees. Step 10, put the cord connection and metal back plate between thumb and forefinger. At step 11, with your free hand, press the touch plate and observe the LED indicators. If the pass indicator lights, replace the cuff. Return to step 2. If the fail indicator lights, replace the cord and return to step 2. Finally, give all failed cuffs and cords to the ESD site coordinator.
The damage to our equipment and the resulting loss of customer service caused by ESD-related failure is something we all need to be concerned with. Industry analyses show that 27 to 33% of all circuit pack failures are due to ESD. This results in thousands of customer trouble reports annually, as well as millions of dollars in circuit pack repairs. It's obvious that we need to focus on reducing ESD events. We can all help eliminate this problem. By joining our ESD control team effort, we can help strengthen each link in our chain of service. Each of us handling a circuit pack needs to follow proper procedures. Now here are some general precautions we can follow to help put an end to ESD-related failures.
Don't remove circuit packs from their protective containers until they are ready to be installed into their appropriate slot and shelf. Don't handle bare circuit packs unless you are properly grounded using an approved wrist strap. Don't hand a bare circuit pack to or receive a bare circuit pack from an ungrounded person. Don't let a person who is ungrounded point out any components on the circuit board you are handling. That could cause an ESD event. Don't let bare circuit packs come within 3 feet of possible sources of static charges. This includes clothing such as nylon jackets or wool sweaters, common plastics such as lunch bags or styrofoam cups, plastic binders or books, or video display terminals. Additionally, don't touch the leads in a circuit pack. Only handle the pack by the faceplate or by the outside edges. Never touch the card edge connector. Don't attach gum labels or Scotch tape to circuit packs. Don't clean circuit pack contacts with anything unless approved specifically for that purpose. Don't lay a circuit pack on anything but an approved static dissipative surface. And always place circuit packs in their approved containers. You'll find these precautions listed in the ESD Job Aid. And if you have any additional questions about electrostatic discharge, contact your ESD site coordinator. Remember, your customers are counting on the highest quality and reliability of service. And if you don't provide that level of service, your competition will. That's why you need to make sure to avoid ESD damage that can zap your business.